Hello everyone. We work at Neo4j and the Gen AI team, and today we will be talking about measuring the performance of VectorRAG versus GraphRAG. So I assume that people in this session are already familiar with the concept of RAG and the different RAG strategies. But in case you don't worry, I'll be briefly explaining those concepts in this session, but I highly recommend you to join the dedicated session. There are plenty of them diving deeply into these concepts. So in this presentation, I'm going to talk about the motivations. So why do we need an evaluation for the RAG strategies and the main objectives behind this work? I'm going also to talk about the different RAG strategies that could be used using Neo4j database. I'll be also talking about the framework that we use for evaluation, which is called Ragas. And we will be also talking about experiments that we conducted and share with you some insights and, of course, conclude with future work. So what is RAG? Why do we need an evaluation for RAG pipelines, and what are the challenges? So RAG stands for Retrieval Augmented Generation, and it's basically when you don't only have a basic interaction with LLM where you only provide an input query and a prompt, and you just receive an answer that is generated by the LLM, but you provide it with a grounding context, which means an additional information that you acquire from external sources, such as documents, APIs, but most interestingly, knowledge graphs. So this has many advantages, but mainly it helps the LLM to overcome the knowledge cutoff. So for instance, there's plenty of knowledge that wasn't present in the training data. And there are also like domain-specific knowledge and confidential data or enterprise-related data. So when you provide the grounding context, you provide this additional information and you help the LLM to answer better the questions and to reduce hallucination. It's also considered as a cost-effective implementation with respect to other implementations such as fine-tuning LLMs. So in general, there are two phases in the RAG pipeline. The first phase is the retrieval phase, where you acquire this additional information from external sources. Here in this presentation, we'll be focusing on the Neo4j database. There are different strategies that you can use in order to get this additional information, and you have different parameters or hyperparameters to configure. For instance, if you're relying on something that is called vector search, you have to configure the K for the top K nodes that can be retrieved from the graph, similar to the query. You can also configure the similarity threshold. We'll be talking about that in the next slides. In the generation phase, the LLM used this additional context or additional information and answer the question. So here also we have different configurations and different parameters to choose. For instance, we have to choose which LLM to rely on in order to generate the answer, the maximum answer size, etc. So here in this work, we added a third phase, which is called evaluation, in order to prove which strategy performs the best, because we have different configuration for retrieval, different configuration for generation. So we want to evaluate each strategy in order to identify weak points and to be able to improve them in the future and monitor, of course, the pipeline and production. So there are many challenges for doing the evaluation. So first, there's currently no standard process for evaluation. And if the evaluation is not automated, it's really very hard to generate a ground truth answer. So it's time and effort consuming. And we also need a framework that can give us an overall score for the evaluation of the whole framework, but also to be able to give scores related to each component of the pipeline. So for instance, for the retrieval part, for the generation part. So here I'm going to talk about the strategies that we used using Neo4j databases. Again, there are plenty of other sessions on VectorRAG and GraphRAG. I also recommend to watch the recording of the workshop on the GraphRAG Python package that was developed by Neo4j, which dived deeply into the concept of VectorRAG and GraphRAG. But briefly, what is VectorRAG and what is GraphRAG? So VectorRAG is when you rely on vector similarity in order to acquire this additional information that we call grounding context. And this is done usually by doing a similarity function between vector of embeddings that represent the query and vector of embeddings that represent some textual properties on nodes in the graph. In the GraphRAG, you basically rely on the power of the graph and the relationship between the nodes to not only acquire information from text nodes, but also from the neighborhood, so from related nodes, thanks to the power of graph traversal. So here in this work of evaluation, we used two different strategies for GraphRAG. The first one is augmented vector search. So you basically rely on vector search to search for the top k similar nodes with respect to a query. And then you rely on those nodes as starting nodes, and then you traverse the graph using a Scifo query, and you can acquire additional information which are concatenated in the context and provided to the LLM. The other strategy that is also considered a GraphRAG strategy is text-to-cipher, and here you basically rely on text-to-cipher to automatically translate a natural language query into a Scifo query. And the Scifo query is executed on your graph, and you get a subgraph, and you can concatenate information from the subgraph and provide it to the LLM to get better answers. So let's say you have a graph, a Neo4j graph that represent movies and actors who acted in those movies. So let's say the embeddings in your graph are generated only on nodes related to movies, and the query is on the movies. Then vector search would do good for this, because it will retrieve a relevant context and provide it to the LLM. But if your query is on actors who played specific roles in those movies, then you get a limited context with the vector search. While with the GraphRAG, you can, based on the nodes movies, and then using a Scifo query, you can traverse the graph and then acquire additional information. And in this case, information about actors will be concatenated in the context, and it will be provided to the LLM. But this requires, as I said, a retrieval query to be configured, which is a Scifo query. Whereas with text-to-cipher, you don't need to configure a Scifo query, because text-to-cipher will automatically translate the natural language query into a Scifo query. It will be executed, and then information related to actors will be concatenated in the context. Now, we used the Ragas framework for the evaluation. I'll be talking about Ragas, and I'll be explaining some metrics that we considered relevant for the evaluation. So we basically looked at different tools and frameworks that are based on an automatic evaluation of a RAG pipeline. I'm sure this is not an exhaustive list. There are plenty of tools and frameworks that could be used, but we relied on Raga specifically, not only because it's RAG-specific evaluation, and it also involved core well-known metrics for the evaluation, and it's open source, but most importantly because it requires no to very minimal human intervention. And if you are also working with other well-known LLM frameworks such as LangChain and Llama Index, it's really very easy to work with Ragas too for the evaluation part, because it offers a good integration with these framework. So Ragas stands for Automated Assessment of RAG System. As I said, it's an open source project, and this is the link of the related GitHub project. It is based on the LLM to provide the evaluation or metrics for each component of the RAG pipeline. So basically, there are some tailored prompts, and they are given to the LLM, so the LLM can generate the scores and evaluation for each component of the RAG pipeline. The good thing with Ragas is that you can get an overall score evaluating the whole RAG pipeline, but also some scores relative to the retrieval and the generation separately. So this is an example of the Ragas metrics that we relied on in this work to compare VectorRAG and GraphRAG. So here, for instance, it's a list for the RAG, for the Ragas metrics that are relevant for retrieval. So some of these metrics do require the presence of ground truth answers generated by humans or by LLMs, but other, like the context relevancy, do not. So for instance, context relevancy, basically the LLM is asked to count the number of statements in the context that were relevant to answering the question. And here by statements, I mean, like, consider the following sentence: Nathalie is a software engineer and works at Neo4j. So here we have two statements. The first one is that Nathalie works at Neo4j, and the second one is that Nathalie is a software engineer. The other two, like context precision and context recall, do require ground truth answers. So here, basically, the LLM is asked to find ground truth elements, either in the first case sentences of the context or in the whole context. Now, there are other metrics in Ragas for the generation part. So for instance, answer relevancy. You ask basically the LLM to infer questions from answers, and then to compare inferred questions with the original one in order to provide a score for answer relevancy. Faithfulness, for instance, you ask the LLM to count the number of statements in the answer that were supported or can be inferred from the given context. And now I'll hand it over to Makbule, who will be talking about experiments.
Thank you, Nathalie. In the rest of the presentation, I will be talking about the experimental setup and the results. We will be talking about how we prepared the data set and which kind of databases we have used. We have used two databases from two domains. One of them is movies and the other one is products. We have used the available databases which are publicly shared on Demo Neo4j Labs databases, so you can access them. We have expanded them by preparing embeddings for them. In these databases, we have some nodes, such as for movies, we have users, movies, actor or director information, and genre. Each of these nodes have some properties. For example, in movies, we know the title or the release year, and we have relationship between these nodes. For example, user has rated a movie, and also we know the property of it. The rating is some value. Similarly, for products, we have product, article, department, and customer nodes, their relationship, and their properties. Next step would be the dataset preparation. As you know, for question answering, such as retrieval purposes, we need a question and ground truth answers. These questions are what users would ask, and users would ask in their natural language question. For example, it can be the user could be asking about the top 5 movies by the IMDb rating, and the ground truth would contain the list of those movies. However, preparing this kind of data sets is not very easy. What we have done is we started with a core set, which are created manually. Initially, we prepared 15 to 20 questions for each domain, and these questions have different complexity levels. We have identified 4 levels. The first one was the basic, very simple questions, which are asking about the properties of the nodes. Let's say, release the year of a movie. And the 4 is the much more difficult questions, the hardest questions, which contain many constraints or aggregations and etc. Having this core set, then we try to expand it. For this purpose, we have used LLMs. In the first approach, we use this core set and ask LLM to rewrite these questions. We asked the LLM to rewrite in a more formal way, rewriting as if it is a teenager, rewrite it using synonyms and etc. The second version of expansion directly uses LLM. Since we already have the schema of the database, we know the relationships, nodes, and properties, we provided this information to LLM and asked LLM to generate questions for us. However, in this step, not all questions are meaningful, or not all of them are relevant to the data we have. As a result, we need a step for human validation. For this purpose, we have used text-to-cipher to generate cipher queries. We collected the output from cipher and compared them manually using the human annotators. Since this step requires human annotators, we were able to collect around 100 question and answers for movies and around 250 questions for products. When we check the complexity levels, we have seen that movies dataset is a little bit more complex. It contains more questions about aggregations. However, products complexity was around 1.6. When we check the results of the experiments, as you know, we have used the Ragas framework. In the next slide, we will see it. We have used, there are 2 kinds of metrics, as Nathalie has already explained, retrieval relevant and generation relevant. When we check the retrieval relevant metrics, we see that GraphRAG strategies, augmented vector search and text-to-cipher performs better than vector search. And when we check the best results usually obtained by text-to-cipher, only exception is context precision. There, vector search performs better, but it is expected because precision is relevant to how many items are returned and how many of them are right. Since vector search are returning a few number of information, having higher precision is easier for that kind of approach. In the next slide, we will see that the generation relevant metrics. Here we see the similar pattern. GraphRAG strategies performs better, and text-to-cipher has better results, relatively slightly better results than augmented vector search. However, there is an exception. As you see, faithfulness value for augmented vector search is very high compared to the others. And we were wondering why text-to-cipher couldn't achieve that result. And we think that it is relevant to how we provided the context to the generator. Since in the text-to-cipher, we have provided cipher queries together with the context we have collected, and we believe that that creates noise for the LLM. That could be the reason why we have a different faithfulness result. When we check the product question answer set, we have similar observations. GraphRAG strategies outperforms vector search results. Except for generation, for answer similarity and faithfulness are very high in vector search, but we believe it is relevant to the complexity of the data set. As I have mentioned, vector search is better at asking questions about properties of the nodes, and for simpler questions, less complex question set, they perform better, and products data set was relatively simpler, less complex compared to the movies dataset. We believe this result is because of these complexity levels. But of course, these things requires many more exploration. When we check the questions themselves, we explore the questions and their answers. As you see, in our database, we are trying to we are looking for the genres of a certain movie. In our database, the genres are different nodes. That means we need to execute one-hop neighbor execution, neighbor exploration. And when we look at the results, vector search is not able to answer the question. Augmented vector search also wasn't able to. However, TeXtDecipher was able to find the right answers. In the next slide, we'll see that a more complex question and answers. This time we are using some aggregations. We are looking for the first 3 genres. We are looking for most rated genres that have the most movies associated with them. And the right answers are seen on the right side of the screen as the expected output. So the results are drama, comedy, and thriller. TeXtDecipher was good at it, and vector search wasn't able to answer it at all. One surprising result is from augmented vector search. It is able to return 2 of the right answers, comedy and drama, but it returns some additional information, like the list of movies relevant to those things, but the numbers are irrelevant because it is not able to access all the database. It is hallucinating some numbers itself based on the knowledge it has. So in short, what we have seen is that GraphRAG strategies are outperforming vector search results. Augmented vector search performance depends on the input of the Scifo retrieval queries. So if you have expert knowledge, if you are able to prepare right Scifo queries, it can perform really well. TeXtDecipher, compared to the others, is more consistent retriever. And for vector search, we can say that it is able to answer questions which are directly relevant to the properties of the nodes, but for others, it has some challenges, struggles. So we will conclude our presentation right now. In this presentation, we have talked about the evaluation and comparison of different RAG strategies. We have explored vector search and 2 graph strategies, which are augmented vector search and TeXtDecipher. We have used 2 domains, movies and products, and relevant databases. We have talked about how we prepared these questions and answers. And as a result, what we have seen is that, in general, GraphRAG strategies outperform the vector search strategies. In the future, of course, we want to use larger data sets, which are well known in the domain, instead of preparing them ourselves. And we want to explore the shortcomings of these strategies and cover them as much as we can. Also, we want to use different data sets from different domains to reveal the shortcomings again. And this is all from us. If you have any question, we can have a live question and answer, or that's all from us. Thank you.